Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good morning or good afternoon to everyone. So for today, my name is Ridhwan Jumaidin, and also the author is Joel et al. From Universiti Teknikal Malaysia, Melaka. So for this paper, we are going to present research titled Water Transport Properties of Thermoplastic Cassava Starch Beeswax Reinforced with Durian Husk Fiber. As the outline, I'm going to present introduction, bio-based polymers, starch, plastics, the modifications, what the methodology, the results, and also the conclusions. So as the introductions, this is the problem that we encounter nowadays with all the plastics, the synthetic polymers. They are non-degradable and non-renewable, so they have created a serious environmental problems upon disposal. So every year around 500 billion plastic bags were used, and as much as 1 million plastic bags are being disposed for every single minute. So this is all data, but I believe this amount is increasing year by year since the populations of the mankind were increasing year by year. So this is the very sad situations happen somewhere in riverside in Philippines, where this guy is trying to identify which kind of plastics that can be recycled. So this is what the critical issues that we faces today. This because they are the plastics difficult to dispose environment, especially like soil, the ocean, a river, and lake, where it says that around about 300 years to photodegrade. So when you degrade in water, even if you degrade, it will pollute the water. So it conveys ethical issues to the human, the wildlife, and also the environment. So it's a very poor situation for the wildlife, especially the aquatic life, like the turtle here. Okay, so here is come the alternative solution. So the biopolymer. Biopolymer made from natural resources. It seems to be a promising approach for these problems because it's biodegradable and also environmental friendly. So among them, starch has been reported as one of the most promising because starch is easily available, is low cost, is biodegradable, of course is renewable because it's planted. So starch, the unique thing about starch, even though it's a powder, but it can become a thermoplastics. Later we show you the video, sorry, the slide, because when the addition of plasticizer, heat and shear, it can become a plastics. So to develop a plastics from starch, the granular structure must be totally or halfway destroyed under high temperature, and shear with the presence of plasticizers such as glycerol, sorbitol, water, and others. This is the SEM image of the structure of the granula. So this is the picture that I said I want to explain to you. So this is how we develop the thermoplastic starch. Basically, the starch will be mixed with the glycerols, and then it will be mixing and then compacted into the mold and undergone hot press for about 1 hour. So then after that, this material will transform into very beautiful and clear thermoplastic starch. Okay. So even though the starch is seems to be like beautiful in terms of the structure, it's a clear plastics. However, it have limitations because the strength is poor, and then the water sensitivity is quite high. So we need to improve the properties by adding some reinforcement to the structure. And in this study, we are going to use natural fiber to reinforce the structure of the thermoplastic starch. Okay, so here we are going to use durians. So durian is the popular seasonal fruits in Southeast Asia, particularly in Malaysia, Singapore, and Indonesia. So and also in the Philippines as well, and Thailand, of course. It's known for its pyramidal spikes on the husk. Only 50 to 65% of durians are to be consumed, while the rest of durian is considered as a waste. So durian waste include the stem, skin, and seed of fruit. Disposal of this waste can result in negative impact to the environment. So hence, durian skin can be a source of natural fiber for reinforcement in TPS. So instead of using Thermoplastic starch as the base materials, in the prior study we have conducted prior investigation by using beeswax to improve the properties of the Thermoplastic starch. And here we can say that the beeswax is able to improve the mechanical properties here, the stiffness, and also reduce the moisture, increase the moisture barrier, and also reduce the water solubility. And then there is no major impact to the structure of the materials following the addition of beeswax. So here in this study we try to utilize the durian husk. Okay, there are some processing to make it become a fiber, such as rotating and grinding and sieving, and then this fiber were added, were mixed with the starch from 0 to 50% of the fiber content. So in this study we are conducting, because we focus on the water absorption properties. So we study presenting the results for the moisture content, the water absorption, and also the thickness swelling. As you can see here, the addition of fiber has significantly reduced the moisture content of the materials. So the decreasing trend can be attributed to greater addition between the fibers and the matrix. And however, for the 50% sample, there is slight increment in the moisture content. Could be due to insufficient fiber matrix weighting in the samples. So this will result in interaction between moisture and also carboxyl group in the fiber. So the fact that it can reduce the moisture content, it means that it can improve the stability of the materials, especially when in contact with moisture. Okay, so in terms of water absorption, this is the result for water absorption. The blue one is for 30 minutes of immersion, and then the orange is for 2 hours of immersions. We cannot conduct immersion for a longer time because the sample started to disintegrate, which shows that it is a good finding, because this material is certainly will become environmental friendly when it can be disposed to water, okay, for disposal. So after a longer period, TPCS shows higher water intake, of course. Okay, so this could be caused by the hydrophilic properties of both the starch matrix and the fiber reinforcement. However, TPCS D40 shows the lowest water absorption here in both time periods. This can be due to the great addition between the starch matrix and the fiber. So evidence of good addition between the two components can be seen in the SM image here. As you can see, this is the fiber, this is the matrix. So the fiber is well bonded, okay, with the matrix. So this is the evidence of the good adhesion. So decrease in water intake for the 50% can be resulted by insufficient fiber matrix weighting, because when there are too many fibers in the composites, so the weighting will become weak, and thus affected the water absorption criteria of the materials. Okay, so here we go for the thickness swelling. So the thickness swelling results is increasing, okay, when the fiber content is increased. So there's some fluctuation here, of course. So the fluctuation can be caused by the non-homogeneous structure in samples. However, the 50 show the lowest thickness swelling compared to the other samples. So this could be caused by the high crystallinity of the fibers and the high water affinity of the water molecule to react with starch. So basically, the starch is more prone to reactions with the water as compared to the fiber. So as a conclusion, biodegradable materials can be successfully developed by using TPCS and durian husk fiber or durian skin fiber. So it seems that there's a decrement in the moisture content and water absorption with the addition of the durian skin fiber. and this indicates that the improved resistance to moisture with the information of SF. However, this finding was accompanied with increase in the swelling of the sample. Nevertheless, this study shows that the addition of this SF able to improve the moisture resistance and water affinity behavior of the samples. So this is the most important things in the study, where it can improve the moisture resistance and the water affinity behavior. So overall, this new material is a potential environmental friendly materials which could be used as an alternative to the petroleum-based plastics. So, as acknowledgement, I would like to express sincere gratitude to Universiti of Malaysia, Melaka, and Ministry of Higher Education for the financial support provided to the research grants and also for the conference proceedings, okay, by publication incentive grant. Okay, so that's all from me. Thank you.